This is still Notes Day 7, Lesson 10.4, Solving Radical Equations. This is Part 2. If you made it this far, Part 1 told you that you have to isolate the radical first. After the radical is isolated, after you get rid of anything extra, you're going to need to get rid of the square root. I can't subtract the 6 because the 6 is actually inside of this radical and inside of a set of parentheses. To get rid of that radical, we're going to do the opposite of square rooting, which is squaring. We're going to square both sides to cancel the radical. So the square root cancels out with the exponent of 2. What doesn't cancel out will be the 2x plus 6. That is now by itself. The right-hand side, you're going to square that. If it's a monomial, 18 squared, that's just 324. Then you're going to solve the equivalent equation. You're just going to solve this like regular. X is being multiplied and added, so we're going to subtract. Then divide, and that comes up with our answer. Most of the time an equation has a solution, and most of the time that solution does solve the original equation when we check it. I don't want to spend the time doing the check, but I promise you that if you plug this back in, 159, into the original x and you evaluate it, 2 times 159 is 318, 318 plus 6 is 324, the square root of 324 is 18, and then we're going to subtract 5 to make 30. That's going to work. All right. So let's get to the bottom of page 26. Now that each of these radicals are isolated, man, these look familiar. Oh, these were on the previous page. Now that all these radicals are isolated, we're going to do the next step. We're going to do the square of both sides, and we're going to solve. And we can check your solutions to determine if they are correct. I will check at least one of these equations. Let's start with number 1. The radical x is by itself. So I'm going to square root it. Oh, excuse me, I misspoke. I'm going to square both sides. The square is going to cancel out the square root, so the left-hand side is just an x. The right-hand side becomes 7 times itself, or 49. This x is solved for. Our first answer is 49. Just a reminder, I should probably have said this earlier. The square root of x is x to the first with an index of 2, or x to the 1/2. When you square a square root, you're going to multiply these exponents, and that's what's going to give you the x. So the exponent cancels out the radical, and you're just left with the x to the first that you started with underneath the radical. I'm not going to check this one. Maybe we'll do the next one. Maybe we'll check that one. The radical is by itself, so we're going to square both sides. When I square, the square root goes away, and I just have 2x minus 3. The right-hand side, 20 times 20 is 400. Now we're going to solve. The next step is to just solve the equivalent equations. We're going to solve this. The x is being multiplied by 2 and subtracted by 3, so we're going to add 3 to both sides. 2x equals 403. Then the x is being multiplied by 2. We're going to divide by 2. X equals 201.5. Okay? Number 3, we're going to square both sides. The square root of x squared is just an x. 9 squared is 81. That's all we had to do. Why don't we go ahead and check number 2? I could use all this extra white space to check that answer. When you check a solution in exercise 2, we're going to plug our answer back into the original equation and evaluate it using forwards PEMDAS, using the regular order of operations. So back in the original, we have a 2 times x minus 3 under a radical. Does this side equal that side? 2 times 200 is 400. 2 times 1.5 is 3, so that's 403. 3 less than 403 is 400. The square root of 400 is 20. And does 20 equal 20? Yes, this answer checks. Part of your homework is to check your solutions. You always check back in the original exercise and make sure that the statement is true at the end. To the bottom row, we're going to isolate the radical. Again, everything in the bottom row has a radical isolated. Step 2, we're going to square both sides. The squaring in the square rooting, they cancel each other out. So now I have 3x minus 22 equals, here's another 400. I'm going to add 22 to both sides. 3x equals 422. Divide both sides by 3. X equals 140.6 repeating. Let's double check that. 422 divided by 3. So it has like 0.66666. I don't want to see a 67 at the end. That 7 is really a 6 that rounds. So let's use the repeating decimal. You could leave it in fraction form if you needed to. It's probably better to plug this answer in as a fraction if you're going to do a check for that one. Exercise 5, we're going to square both sides. So I have x divided by 3 equals 4. The x is being divided, so what cancels division? Multiplication. We're going to multiply both sides by 3. 3x divided by 3 is x. 3 times 4 makes 12. And there's your solution for that one. Number 6 is going to take us a little while to get through. We're going to square the left-hand side to cancel the radical. But the right-hand side is a binomial. And if you remember back to the warm-up, when you square a binomial, that means we may need to use a box. The left-hand side is x plus 3. The right-hand side, you could use the box. There's a different shortcut. Square the first thing, multiply together and double, square the last thing, but we'll just do the box. I think we're more comfortable with that. X times x is x squared. 3 times x is 3x. X times 3 is 3x again, and 3 times 3 makes 9. The right-hand side becomes x squared plus 6x plus 9. The equation that we have now is quadratic. That means we're going to have to solve it just like the warm-up, either by factoring or using the quadratic formula. Before we do any of these things, we're going to have to set this equation equal to 0. X squared plus 5x plus 6. We could use quadratic formula, but factoring is sometimes easier and quicker. Our AC number, or just a value of C, is 6. Our target number is 5. Are we going to use 1 and 6 or 2 and 3? 1 and 6 makes 7. 2 and 3 makes 5. These are the right pair. So 0 equals, we're going to do x plus 2, x plus 3. Then we're going to split. X plus 2 equals 0. X plus 3 equals 0. Then we're going to solve. We're going to subtract 2 on both sides. X equals negative 2. We're going to subtract 3 on both sides. X equals negative 3. Since there are 2 answers, we do need to do 2 checks. I'm going to do it using mental math. Let's start by plugging in negative 2 here and here. Negative 2 plus 3 is positive 1. The square root of positive 1 is 1. Negative 2 plus 3 is also 1. So 1 equals 1, which means this answer checks. I can circle it. Let's try negative 3. Negative 3 plus 3 is 0. The square root of 0 is 0. Negative 3 plus 3 again is 0, and 0 equals 0, so that's true. Both answers work. Well, of course they work, right? Don't they always work? I'm not sure they are always going to work. Let's continue on. On page 27, we have new equations that look a little different. It says solving equations with radical terms on both sides.